So, if you're building anything with large language models, you've probably hit the same wall we all have. They know pretty much everything on the public internet, but they know absolutely nothing about your world, your private, internal data. So, how do we fix that? How do we teach an AI about us? Okay, let's get into it. Think about it. Your shiny new AI can write a beautiful sonnet about Shakespeare. No problem. But can it tell you about your company's latest support policies or find a specific customer's order history? Nope. That right there, that's the context gap. It's this massive blind spot that separates a clever toy from a genuinely useful tool. Our job is to bridge that gap. All right, to solve this, two really powerful approaches have popped up. Let's start with the first one. I like to think of it as the librarian. Its official name, though, is Retrieval-Augmented Generation, or just RAG for short. RAG basically gives your LLM a library card to your company's private collection. So instead of just winging it based on its general knowledge, it actually grounds its answers in your specific documents, your manuals, your knowledge bases, and that makes its responses not just relevant, but factual. The process itself is actually pretty straightforward and elegant. When a user asks something, the system first retrieves the most relevant docs from your knowledge base, which is usually a vector database. Then it augments the original question, just tacking on that retrieved text as extra context. And finally, it hands that whole package over to the LLM to generate a really precise answer. So it's just retrieve, augment, and generate. Simple as that. Now here's where it gets really interesting, because this is where you decide if RAG is right for you. It absolutely shines with data that's unstructured and pretty static, or at least data that doesn't change all that often. We're talking about the bedrock of your company's knowledge, things like PDFs, internal wikis, FAQs, blog posts, you get the idea. And that right there perfectly highlights the one big limitation of the librarian model. A library is fantastic for knowledge that's already established. But what happens when the information you need isn't in a book? What about data that's alive, changing every single second? So that brings us to our second solution, which is built to tackle that exact challenge: real-time information. If RAG is the librarian, then this next one, well, it's like giving your AI a tool belt with a bunch of live tools it can use on the fly. I absolutely love this quote because it just nails the whole concept. The Model Context Protocol, or MCP, is basically the USB-C port for AI. It's this one standard plug that lets any AI model connect to any live service. And boom, it just works. So instead of reading from some static library, MCP is a protocol that allows the LLM to securely go out and grab live, structured data. It's not reading a document about your data. It's interacting with the data directly by using tools, like calling an API or querying a database, at the exact moment it's needed. So you see, the crucial point here is that MCP is designed for a completely different kind of data. This is for information that's dynamic, structured, stuff that needs real-time access. We're talking about checking an order status in a database, pulling current inventory levels from an API, or fetching a user's live account details. Okay, so we've got our librarian, RAG, for all that static knowledge, and we've got our live toolkit, MCP, for dynamic data. So now, let's put them head to head, a little showdown to really hammer home the differences. Really, when it comes down to it, the choice between them boils down to one fundamental question. Does your AI need to access a library of what you know, or does it need a set of tools to find out what's happening right now? And this comparison makes the distinction crystal clear. RAG is for your static, unstructured files, your docs, retrieved through a vector search. MCP, on the other hand, is for dynamic, structured systems accessed with on-demand tool calls. And this difference in how they integrate with your systems also has a huge impact on security. MCP can use protocols like OAuth 2 for secure, real-time access, which means you don't have to preload sensitive data into a whole separate database. That's a big deal. But here's the real kicker. In the real world, complex problems almost never fit neatly into one box. The most powerful AI applications don't make you choose. They become a hybrid powerhouse, combining the best of both worlds. Okay, let's walk through a super common customer support scenario. A user messages your bot and says, "Hey, I can't log in. Also, was I charged twice for my subscription this month?" Now, that one question actually needs two totally different kinds of information to answer it properly. So first, to handle the login problem, the system uses RAG. It goes and pulls the standard, static troubleshooting steps right out of the product manual. That's our librarian grabbing the right book off the shelf. But at the same time, to answer that billing question, the system uses MCP to make a secure, real-time call to the live billing database. It checks that specific user's recent transactions. That's the live tool in action, getting up to the second facts. The LLM then gets both pieces of the puzzle, the general knowledge from RAG and the specific live data from MCP. It puts them together and synthesizes the single, perfectly tailored response that's both super helpful and 100% accurate. So, why are we spending all this time on this distinction? Well, because understanding the difference between static knowledge and live data is the absolute key to building AI applications that aren't just clever, but are actually useful and reliable. You know, the biggest takeaway here is that there's no single best solution. The right choice, whether it's RAG, MCP, or a hybrid of both, it depends entirely on the kind of data you have and the types of questions your users are going to ask. It's all about matching your architecture to your actual use case. This quote just puts it so perfectly. The goal is to find that balance between long-term knowledge and real-time precision. The very best systems are what you might call static aware. They can draw from a library of established wisdom, but they're also state aware, meaning they can act on live, up-to-the-second facts. So, as you go off and design your next AI system, I want to leave you with this one question to guide you. Don't just ask, what does my AI need to know? Instead, ask yourself, what does my AI need to do to get the most accurate, timely information possible? Because the answer to that question, well, that's what will truly define your architecture.